All right, student, good morning. First, I hope you have had a very nice study break. Today, we are going to restart our engine to learn. Okay, so chapter 7, the new chapter, risk and return. All right, so first, I like to highlight this variable, return. So return is a key variable in finance. For me, return is an exchange rate between money over time. That means between today's money and the future money. When we do the time value calculation, we need the return. In the previous discussion, we give you the return directly. And now we are going to show you how to calculate the return. And risk, we know return depends on risk. So in this chapter, we are going to show you how to calculate return and risk. The answer is here. We use a market data. So market will determine the price. Then we use the price data to calculate return and risk. All right. And we know the return and risk, they have a relation. I mean, high risk, high return, low risk, low return. So we are going to discuss the RR relation in more detail in this chapter. Right? We not only show you the direction of the relation, I mean, high risk, high return, low risk, low return. We also quantify the RR relation. All right, so we will show you a model to quantify the RR relation, right? Okay, so let's follow our point slide. So in chapter 7, we have 6 topics. All right, sorry, we have 5 topics. So in today's lecture, I hope to cover the first 3 topics. All right, the first topic is RR relation, return and risk relation. Right? Then we show you how to measure the return. Next, how to measure the risk. All right, so it's for our today's lecture. So risk and return relation. What is the relation? So first, I need to remember the rate of return that investor require for investment depends on the risk associated with the investment. The greater the risk, the larger return investor require as a compensation for bearing the risk. So for me, risk is a compensation for taking the risk. So when we take higher risk, we will require higher return as a compensation. All right. And the return in finance, we use a rate of return. So we use a percentage return. So later I will show you 2 measurements of return, dollar return and the percentage return. But in finance, we use a percentage return. All right. So next slide. So why we have the relation, right? Risk and return relation. Why? So again, the relation, the greater the risk, the greater the return, right? We know the relation. So a consequence of this idea is that investors want the highest return for a given level of risk or lowest risk for a given level of return. So when choosing between 2 investments that have the same level of risk, investor will prefer the investment with higher return. Right? So they will require higher return to invest in the riskier asset and willing to accept lower return on less risky asset. Right? So it's about investor. So why we have the return and the risk relation is due to investor choice. Right? So let me use my handwritten note to show you how investor can affect, the relation, RR relation. So let's use the ratio, is a return to risk ratio, R ratio. So consider two stocks, stock A and the stock B. If stock A is RR ratio is higher than stock B's RR ratio, right? So stock A higher RR ratio, higher return compared with the risk. So investor will do a choice. They will invest or buy stock A, right? And sell stock B. When investor buy stock A, the RR ratio to stock A will go down, right? Sell the stock B, RR ratio of stock B will go up until balance. So let me show you that more detail. So when this is the return, the definition of return. Return is P1 minus P0 divided by P0. So P0 is stock price today. All right. So you buy the stock at P0. And at year one, P1, the difference between them is your capital gain. All right. So you can see when we buy the stock, higher demand, higher price. So price P0 will go up. So when P0 is going up, you can see the return will go down. Right? This is why you can see when investor, they see the stock A has a higher RR ratio, they will buy stock A. When they buy the stock A RR ratio will go down. All right. On the other hand, you can see when we sell the stock, the stock price will go down, right? And the return will go up. Right? So why we have the relation between risk and the return? The reason, investor, right? Investor will choose between two investment based on return and risk. Right? Okay, we finished the discussion on the first topic. So again, let's review some key concepts for you. So RR relationship. So first, I remember return is a compensation for bearing the risk. Right? So the greater risk, the greater return. On the other hand, the less risk, the smaller return. All right. And the market will keep this relation, the market efficiency. Please refer to our chapter 2. All right. So key insight is competition among investor and the trader make a market efficiency. Because of market efficiency, we can see the risk return trade-off. Right. So taking more risk, investor will require higher return. Right. Okay, so I think students should be okay with this like a principle. Is a key principle in finance. All right. Now we are going to show you the detail how to measure the return. Next, how to measure the risk. And finally, we will discuss the relation again using the model, the CAPM model, capital asset pricing model. So we use the CAPM model to quantify the RR relation. Right. So first, let's show you how to measure the return. So first, we introduce a dollar return. So when people refer to the return from investment, they are referring to total return over some investment period or holding period. And the total holding period return consists of two components. One is income component, direct cash payment, such as dividend to stock investor, or interest payment to bond investor. This is an income component. Second component is price change, right? Is capital gain or capital loss. So again, let me use the image to show you the two components. So here we use the stock as an example, right? If you are a stock investor, so today T0, you buy the stock. I use negative, mean outflow. So you buy the stock at P0. This is outflow, negative P0. And you hold the stock for 1 year. So at year 1, you sell the stock to receive P1. And over the 1 year period, you receive the dividend. All right. So now you can see two return component. One is the income component. Income component is dividend. The second component is price change or capital gain or loss. So capital gain or loss is P1 minus P0. Right. So this is the return. So we have two return component, right? Income component and the price change. Not only stock, let's consider house. If you are a house owner, you also have two components for your return. One is income, like a rent. You can rent out your house to someone, right? Rent, the income component. The other one is the price change. If you sell your house, you will have capital gain or loss. That means P1 minus P0 might be negative, will be capital loss. Right? So this is a dollar return. Now we are going to show you percentage return. Right? So in finance, we use the percentage return. Right? So percentage return is a dollar return divided by initial investment. Right? So here is our equation. So you can see I use the return. R is our return. T is our time period. All right. So P1 minus P0 is our capital gain. Plus CF is our income component. Right. This is the dollar return. Dollar return divided by initial investment. So at T0, we buy the stock and we pay P0. This is our initial investment. Right? Then you can see P1 minus P0 divided by P0, we define the CA. RCA is the capital gain yield or capital gain return. Right? So P1 minus P0 divided by P0, capital gain yield. And the CF1 over P0 is the dividend yield. So yield is a terminology in finance. So yield for me is a return, percentage return. All right. So we have percentage return of dividend and percentage return of capital gain. All right. So this is a measure of return. Now, next slide, we discuss expected return. So we calculate expected return in finance in the same way that we calculate any expected value. So I like to highlight this word, expected. So again, I use my handwritten note to explain what is expected. So this is our timeline. So in our previous discussion, we know today we buy the stock at P0. So it's a cash outflow, negative P0. Right. At year 1, we sell the stock to receive the P1. All right. But we like to mention a point. P1 is a RV. RV is a random variable. I mean, today we stating here T0. P1 is a random variable. It's an unknown variable. We don't know P1. All right. And we know P1 is a random variable. That means P1 will have many possible values. All right. So P1 is a random variable. So return will be a random variable. So P1 has many possible values. Return will have many possible values. Right. So we have to use your statistical knowledge, right? The random variable. So And we have a probability. For each outcome, we have a probability. And the sum of the probability will be equal to 1. All right, so PI will be an unequal probability. Right, so we have many possible stock prices, stock price at year 1. P1 is a random variable, so return is a random variable. When I see a random variable, I know they have different outcome. And for each outcome, we have the probability. The sum of probability is equal to 1. Okay? Then we calculate the expected return. So if you know the random variable and the probability, expected return is a weighted average of the possible return from an investment. All right, so here is our equation. So we have return, but now I add a variable I. I mean we have different outcome, I from 1 to n. All right, PI is the corresponding probability. So our ER, expected return, is here. And you can see this is a weighted average. This notation is summation, right? So we have the probability times the return, and adding up, we have the weighted average, right? It's our expected return, okay? If you are okay with the expected return, now we are going to the next slide. So a special case of expected return. So this is our special case. Each of the possible outcome is equal. That means P1 is equal to P2, equal to P3, equal to P, and it's Y over N. The formula will reduce to a simple average or equally weighted of the possible return. So you can see we have the simple average. This is a special case if the probability is constant, right? All the possible outcomes are equally, I mean, they have the same probability to occur. Okay. All right, so we finished the discussion on measure of return. So again, let me review the key concept for you. So for return, we discussed the dollar return and the percentage return. All right, I know how to calculate dollar return and the percentage return. But please note, in finance, we use the percentage return. All right, the reason is simple. Comparison. All right, so when we do the comparison between different investment, we use a percentage return. All right, so because percentage return consider the initial investment. All right. Next, so dollar return is income component plus price change. So percentage return will be dividend yield plus capital gain yield. Right. Again, when I see the yield, that means return, percentage return. All right, we have dividend yield and the capital gain yield. Next, ER. I know return is a random variable, right? So we have the probability, PI, right? So N denote the total number of days of the economy. Right? For example, N could be 2 states, right? Good year versus bad year. And the RI is a return in state I. The PI is a probability of the state I. Our ER will be the weighted average. Or you can use the notation, summation, to show the ER. Right. Okay, so I think return should be okay for our student, right? The calculation is not difficult, weighted average. However, you need to know why we use the expected return, because return is a random variable. So we use expected return, right? Now we are going to show you risk, the measures of risk. The calculation will be more difficult. So the risk. So how to calculate or measure the risk? We use the variance and the standard deviation. So variance and the standard deviation, they are the two most basic measures of risk, right, in finance. Right. Okay. I believe most of students, should be all of students, they learn variance and the standard deviation in their statistics courses, right? So here is to review your statistical knowledge, right? Variance and the standard deviation. But again, I like to explain variance and the standard deviation in a finance way, right? Not a statistic way, right? So let me show you next slide. So how to calculate the variance and the standard deviation. Okay. So you can see here we show you the process. The better approach would be to square deviation. This makes all the numbers positive, and then multiply each deviation by its associated probability before summing them, before summing them up. Right? This calculation yield a variance, or I use a sigma. This notation is sigma square, right, of the possible outcome. The square root gives us the standard deviation. This notation is sigma of the possible outcome. So finally, we have this result, right? Variance of return, right? Sigma square, and it's here. Okay, so I like to break down the calculation in several steps. Right? When I calculate the standard deviation, I have the 4 steps. Right? Step 1, we calculate the deviation. Right? Deviation from the expected return. This is step 1. Step 2, square the deviation. Step 3, calculate the weighted average of the squared deviation. Then we have variance, or sigma square. Step 4, we use the square root to have standard deviation. This is our final result. All right, this is the measurement of risk. Right. So now we are going to show you an example, and you will see how we do the 4-step process. And let's return to our formula. So this is our formula. You can see the 4 steps. So step 1, calculate the standard, calculate the deviation. So you have the ER. ER is the average or the mean. So RI minus ER is a deviation from the mean or from the ER, right? Then second step, we do the square deviation. We square the deviation. You can see the power of 2, right? Next, weighted average. So you can see we have the PI. PI times the square the deviation, and adding up the weighted average. Right? This is the variance. In the final step, square root. All right. So let's do an example. You will see how we calculate the standard deviation. So consider 2 stocks, C. So consider 2 stocks, C and T, right? So you can see the states boom, normal, recession, right? So boom, a good year, recession, bad year, and the normal year. Then the corresponding probability, right? And we have the return for 2 stocks, right? So first, I like to highlight about the probability. So you can see unequal probability, and the sum of the probability is 1. Okay. Next, we calculate ER. So I hope the ER, expected return, is not a problem for our students. So ER is a weighted average. So for star C, we have the ER 9.9%, T 17.7%. This is the ER, right? Next, we calculate standard deviation. So please remember the step. So now we show, next slide, we calculate the standard deviation. So you can see the process. Let's focus on star C first, right? So you can see first I calculate the deviation from ER. So 15% minus 9.9%. This is a deviation from ER, right? For Boone State. Next, 10 minus 9.9, deviation from ER. 2 minus 9.9, deviation from ER, right? The deviation step 1. And we square the deviation. So you can see the power of 2, right? Next, weighted average. We have the probability for each state. So probability here. So weighted average, this is our result. This is the sigma square, variance. And sigma will be the square root of variance. The final result is 4.5%. I have a note here. So you can see when we calculate the risk or the standard deviation, we do the square deviation first. Then we use the square root to have the standard deviation. So we square deviation, then we use the square root to remove the square, right? The reason is if we don't do this way, if you do the weighted average directly, you will find the sum of deviation will be 0. Because your deviation could be positive or negative, right? To make the result to be positive, we use the square, right? The reason is simple. Both positive deviation and a negative deviation is a deviation, all right? They are a deviation, no matter it's positive or negative, right? So we use the square first, then use the square root, right? So some students might ask me why we don't use the absolute value. Yes, we can use the absolute value, right, to do the calculation. But in finance, we prefer this way, square first, then square root, because square has some good calculation characters, right? But it's out of our business. We don't need to focus on the calculation, all right? I just have a note for you why we have the square first, then do the square root, right? So this for star C. About the star T, again, you can do the calculation yourself, right? So you have the ER and you have the return for each state. So you can go through the process yourself. First step, deviation from ER. So 25 minus 17.7, 20 minus 17.7, 1 minus 17.7. Then square deviation. Next, weighted average. Right. Finally, square root. So let me show you the calculation for T. So you can see the deviation here in the parentheses and the square deviation, right, power of 2. Then weighted average, right, this is our variance. To have standard deviation, we use the square root. This is our final result. Right. Okay, next slide. Interpreting the variance and the standard deviation. So variance and the standard deviation are used for measure of risk for variable they are normally distributed. Okay, they can be represented by a normal distribution. So now we are going to show you distribution, a normal distribution. Right? I believe students, you learn normal distribution in your statistic courses. However, we like to explain the normal distribution in a finance way. All right. So normal distribution is a symmetrical and bell-shaped frequency distribution that is completely described by its mean, average, and standard deviation. So for the normal distribution, we have two parameters. One is the mean. Mean is the ER, expected return. The other one is standard deviation. Standard deviation is the risk. Right. Okay, so next slide, we show you the a graph of normal distribution. So you can see the vertical line is the probability, and the horizontal line is our return, right? Like I say, return is a random variable. So you can see we have different value or different outcome for the return, right? And for each outcome, we have the probability. And we have the distribution look like this, right? Okay, so we like to discuss the distribution further. So first, symmetrical. So symmetrical means, for me, it's like a balance. So you can see the mean is our ER, right? So the probability of the observation lower than ER is equal to the probability of the observation higher than ER. Right? So ER is our expected return, or the mean. So in the final discussion, we use the mu to stand for ER. All right. So probability lower than ER is equal to probability higher than ER. So symmetrical, right? Normal distribution. And the bell-shaped. So you can see the shape look like a bell. So for me, a bell-shaped means we have more operation in the central area and the less operation in the tail, right? So you can see in the central area, we have higher probability. In the tail, lower probability, all right? And next, so the mu is our mean. Mean plus minus 1 standard deviation, the probability is 2/3. The mean plus or minus 2 standard deviation, the probability is 95%. Right? For the range, higher than 3 standard deviation or lower than 3 standard deviation, the probability is 99%. We don't need to remember that, all right? This for statistics student, they need to remember that. For finance student, you don't need to remember that. I just write it down. But for me, the normal distribution, like we have more observation in the central and the less observation in the tail. So the distribution normal. Normal means typical, right? For our real life data, we have the distribution, normal distribution, okay? The next slide, we show you the normal distribution with high standard deviation and the low standard deviation. So we consider the data, the return. We have two return, right? One is the standard deviation, 2%. The other one is the standard deviation, 3%. All right. So you can see the difference between the two investments. So standard deviation 2%, the blue curve 3%, standard deviation the orange curve. So overall, you can have this conclusion: higher standard deviation, higher risk, right? And you can see your distribution will be more divergent. On the other hand, low standard deviation or low risk, your distribution will be more centralized. Okay, so we can use the shape of the distribution to identify high risk or low risk. Okay, so if you have high risk, your distribution will be more divergent. That means you have more observation on the tail. So tail means your return could be either very high or very low. Okay. On the other hand, if the risk is small, your distribution will be centralized. Right. Most of your return operation will be in the central area. Okay. Next slide, we show you the realized data. Right. So historical market data. Here we consider return on equity. That means stock. Right. And the return on bond. We have government bond. Return on bill, and 90 days, that means short-term bond, right? Short-term bond. So we show you the real-life data. We have return of stock, return of bond, and we have long-term bond and the short-term bond. And here you can see the distribution. So equity return will be more divergent. So you can have oscillation on the tail. And for bond, you can see the distribution will be more centralized. Okay. So overall, you can have the conclusion here. Let me show you our conclusion here. So for financial asset, we have stock or equity or bond, right? And the stock, we have small company stock, large company stock. For bond, we have corporate bond and the government bond. Government bond, we have long-term government bond, short-term government bond. Right? So we have different financial assets. For this financial asset, if we discuss the risk, you can see the risk is from high to low. So small company stock, higher risk, right? Then large company stock, then bond. So short-term government bond, lowest risk. If you collect the data to have their distribution, small company stock, their distribution will be more, you can see that they have more oscillation in the tail, right? And the short-term government bond, their distribution will be centralized, right? Okay, so here we just show you the realized market data, and we have the conclusion here. So next slide, we discuss historical market performance. So in the market data, we can always find a higher standard deviation of return have been associated with higher return. So in the realized data, we can find the high risk and the high return. Okay, and the financial analysts often use the historic number such as this to estimate the return that might be expected in the future. So let me show you my handwritten note here. So let's consider you are the financial analyst. You want to know the distribution of the return. So T0, you are looking for the future, and the future return is a random variable. So we have R1, R2 to Rn, right? We can calculate ER and the standard deviation. This is unequal probability, right? This is a future return, but no one knows the future, right? No one knows the future. So financial analysts, they use historical number to predict the future. So today, T0 analysts will go back, for example, go back 1 year. Then they collect the return for each day, R1, R2 to RT. All right. So they'll go back, for example, 1 year. collect the historical return. Then they calculate the sample average and the sample standard deviation. Please note, in the calculation, we use the equal weight. That means for each observation, the probability is the same, 1 over t. If you go back for t days, all right. So each observation, the probability is 1 over t, right? So we calculate the sample average and the sample standard deviation to predict the ER and the future standard deviation. Okay, we finished the topic. So again, let's review the key concept for you. Measure of the risk. So I know this formula, right? So to do the variance, you have several steps. So let me show you the steps. Step 1, deviation from ER. Step 2, square deviation. Step 3, weighted average, right? Standard deviation, the final step, square root of the variance, right? This is our standard deviation. Then normal distribution is a common probability distribution. So ER, or the mean, measure the central tendency. Standard deviation is a measure of dispersion. And historical return on security have the probability distribution that are approximately normal, right? That means if you look at the historical data, you have more observation in the central area and then less observation on the tail. So this is why the distribution is normal or typical. And when we check the historical record, and we can find the greater return, the greater risk. All right. For example, you can make a comparison between small company stock, large company stock, long-term government bond, short-term government bond. You can see the risk from high to low, right? Okay, we finished today's lecture. We have 2 more things to do. So let me show you. One is the reminder, right? So I want to remind you, we will have the test 1. So let me show you the test 1. So I'd like to remind you again about our test. So we will have test 1 on this Wednesday. All right, this Wednesday is very important. The time for the test is 6 p.m. Right, 6 p.m. is not your normal school hour. Please know the time. And section A should be okay. Section A will have 12 multiple choice questions, but please pay attention to section B. We will have 3 long answer questions. So you need to handwrite your answer. All right. So to submit your answer, for example, like this. All right. So I will ask the student to hand draw the timeline, right? And show me the detail of the calculation process. All right. Please understand it's necessary because AI is too powerful. AI cannot create a timeline for you, right? So please follow my instruction to do the test. All right. If you have questions, you are welcome to write me the email. One more thing, attendance recording. Let me show you the QR code. Right, student, you can use a QR code to record your attendance today. So thank you for attending. Good luck with your test one.